as I mentioned earlier, we need to be able to work out the direction a little bit more specifically than just saying northeast or southwest or whatever. There's two different ways of doing this, but one of them requires a protractor, and I suspect lots of you don't have a protractor at home, and the other one, you need to be able to use Pythagoras and trigonometry, and I know that some of you haven't done this in maths yet. So the first part of this video, everybody should be happy with. The second part, if you've not done Pythagoras or trigonometry yet, don't watch the second part, because I don't want you to get totally confused. Okay, don't worry about it, we'll come back to it later. But this first bit is how to work out angles using a scale drawing. So we've drawn the triangle just like we've done before and drawn it to scale. So we've got 1 centimetre equals 100 metres. So if we're working out displacement, all I would need to do is measure the length of this side, and that is coming out at 15.5 centimetres. So if that's 15.5 centimetres and each centimetre is 100 metres, then that's going to be 1,500 metres. If you have done Pythagoras, you should know that the hypotenuse, this side of the triangle, is always the longest. So you should always expect this number to be slightly bigger, than either of these two. Then you'll have an idea if you've done it right. So we know the displacement's 1,500 metres, and previously we would have just said, oh, it's northeast, but we actually need to be able to work it out slightly more accurately than that. And what we do is what's called a 3-figure bearing that we take from north, and this is something that you might do in geography at some point. And what we need to do to work that out is you get your protractor, and we're trying to work out, we're basically measuring the size of this angle, okay? So line it up so that the corner of this triangle is at this point here. This is your 0 line here, and then we're doing it from north, so we're basically working out how far around it is from north. It's about here, which would say 40 degrees. So that's 40 degrees, but we actually write it as a 3-figure bearing, which basically just means we stick a 0 in front of it. So the displacement here would be 1,500 metres at 040 degrees, and that would be our answer. Okay, so that's done using a scale drawing. If you use a scale drawing, you can just measure it with a protractor. The other thing you can do, so at this point, if you've not done Pythagoras or trigonometry, you can switch off. The other way we can do it is we don't need to do a scale drawing, we can just draw a triangle. So we've got the same thing again, I've just stuck a couple of distances in it, but this time I've not drawn it to scale, I've literally just drawn a triangle. And what we can use is Pythagoras. Now I don't know how you lay out Pythagoras, I know the A's and the B's and the C's sometimes get written differently, but I'll do it just the way I do it. So we can use Pythagoras to work out the length of this side, where we say a squared equals b squared plus c squared. We'll call this b squared, this side would be b, so it'll be 400 squared plus 1,200 squared. Stick that in the calculator. 400 squared plus 1,200 squared gives us a big number. 1, 6, 1, 2, 3, 4. And then a is the square root of that. So square root of our answer gives us 1,265. I'll just round it to the nearest metre. So 1,265 metres. So that's the length of that side, 1,265 metres, because this is in metres. And again, that makes sense because it's slightly bigger than the longest side. So now what we need to use is a bit of trigonometry to work out this angle. So this angle we would then do would be tan theta opposite over adjacent. So tan theta equals 1,200 over 1,265, which means that equals tan to the minus 1 of 1,200 over 1,265. And then when we stick that in the calculator, we get 43.5 degrees. But then we don't worry about the 0.5, so we'd actually just round that up, and we would then call that a bearing. We'd then say that the displacement is 1,265 at a bearing of 0, 4, and then I'd round that up, 4 degrees. And that's it. So that's how to work it out using Pythagoras and trig, which you can do if you want to, but as I say, don't worry about it if you've not done that in maths yet.